In class you've learned about already what it means for two lines to be parallel. Two lines are parallel if they don't cross each other. If when we have our graph, we have that line, and we have that line, and they're always exactly the same distance from each other. Two lines are perpendicular if they cross, but specifically they cross at right angles. If they intersect at a right angle. In other words, one that is 90 degrees. 90 degrees would be the measurement of that angle. So, like those, actually the x and y axis, those are perpendicular to each other. So that's a good way to think of it. There's a symbol that we use for when two lines are perpendicular, and it's to do this little upside down T. So this means, if you see this symbol, that means automatically that the two lines are perpendicular. So if you have line M is perpendicular to line N, then, well, that's what that means. It means that they're perpendicular to each other. So the question is, how do we know? We could get a protractor and we could measure, or we could look at the slopes. Because remember, if two lines are parallel, that means they have the same slope. If two lines are perpendicular, though, it's not that their slopes are the same, it means that their slopes actually are related to each other in a very specific way. We can say that two lines are perpendicular from their slopes. Two lines are perpendicular if their slopes multiply to -1. If their slopes multiply to -1, then we can show that they are perpendicular to each other. And it's as easy as that. We look at the slopes. If they're the same, then they're parallel. If they're not the same, but they multiply to -1, that means they're perpendicular. So let's just go ahead and start doing that. We have two equations. Y equals 3x plus 4, y equals 5 plus 3x. Right away, I'm going to rewrite this. Y equals 3x plus 5. Slope of this line is 3. Slope of this line is also 3. They're the same, so they're parallel. Same slope, parallel. Nothing more really needs to be said. If they're the same slope, then they're parallel. 3x plus 4, 5 minus 3x. Again, I'm going to rewrite that. Y equals -3x plus 5. So I have a 3, and I have a -3. The slope of this is 3, the slope of that is -3. They're not the same. Right away I know they're not parallel. I got to check to see if they're perpendicular. And remember, they're perpendicular if they multiply to -1, but of course they do not. They multiply to -9. So these are not perpendicular. They do cross, but they don't cross at right angles. So they're neither perpendicular nor parallel. 1/3 x plus 4, y equals 1/3 x plus 4, y equals 5 minus 3x, which again I'm going to rewrite as y equals -3x plus 5. I think you can see what's going to happen here. I have, again, they're not the same, the 1/3 here and the -3 here, but if I do 1 over 3 times -3 over 1, let's go ahead and put that there, I get 1 times -3, and I get 3 times 1, and they cancel to -1, and so they are perpendicular. All fine and good. Sometimes, though, you have to work at it a little bit more. Like with the last example here. Y equals 2/3 x minus 8. And then we got 3x minus 2y equals 16. Clearly the slope from this thing is 2/3. I don't need to do anything to figure that out. But I got to solve for y here in order to get the slope. 3x minus 2y equals 16. So I'm going to minus the 3x, minus the 3x, because that's a plus a -2y, so that stays a -2y. I can't combine the 16 and 3x. There's no x there, so I just write -3x plus 16, mostly because I always want to have the x first. It kind of makes sense. And now I have to divide everything by -2. Not just one thing, everything. Everything gets divided by that -2. This gets divided by a negative 2. Negative 2 divided by negative 2 is 1. We have just a y on the left. And then I have negative 3x divided by negative 2 and positive 16 divided by negative 2. It breaks up. Everything gets divided by that. Negative 3 divided by negative 2 is just 3 over 2. These negatives cancel, but the numbers don't. Negative 3 has x, and then 16 plus negative 2, or divided by negative 2, is negative 8. So I have y equals 3 halves x minus 8. And I have y equals 2/3 x minus 8. The slope of this is 3 halves. The slope of this, the first line, was 2/3. 2/3 times 3 halves is positive 1, not negative 1, positive 1. This does not count. This does not mean they're perpendicular. They're obviously not parallel. They're not perpendicular either. They don't multiply to negative 1. They have to multiply to negative 1 in order for them to be perpendicular. Last thing that we'll check is we can solve a little kind of fancy algebra problem using the fact that they're supposed to be perpendicular. I want to find A, over here, if y equals negative 1/4 x is perpendicular to y equals 7a minus 10 times x. So I have this equation, y equals negative 1/4 x. The slope of that equation is negative 1/4. The perpendicular slope, then, is whatever I would get by, or whatever makes that multiply to negative 1. It's a little bit of a hard question to answer, so what I want you to have into your head is this idea. Negative reciprocal. It's easy to check if two possible slopes multiply to negative 1, but if you have one and you need the other, think of negative reciprocal. In other words, get rid of the negative sign, or put one on there if there isn't one. Switch the sign, and then flip the fraction. Switch the negative to a positive, flip the fraction to 4 over 1, positive 4 over 1. These are negative reciprocals of each other. This is negative that, they are opposite sign, and they're opposite orientation. They've been flipped. So what that means then, if this line is supposed to be perpendicular to that line, then that means 7a minus 10 has to equal 4. So now it's easy to do. Plus 10 plus 10, 7a equals 14, so a equals 2. And that's that. Remember, perpendicular lines, the slopes have to multiply to negative 1. If you have slopes to check, you can just multiply them and see if it works out. But if you need to know what slope it is in order to get a negative, in order to get to the two of them to multiply to negative 1, just do the negative reciprocal. Negative 1/4, positive 4 over 1. Positive 2 over 3 would need negative 3 over 2. This was already perpendicular. Positive 3 would require negative 1 over 3. So flip the sign, positive versus negative, and flip the fraction. 1/3 versus 3 over 1. 3 over 1, 1 over 3, negative, positive, they're exactly opposite each other. They are negative reciprocals.